Okay, so here's the final exam for consumer and producer theory, which is actually advanced microeconomics for graduate level course. Um, yeah, let's. I think it's 4 questions, so let's try and solve this final exam. So the first question tells me let the binary preference R be transitive. And remember, R is usually denoted by the weak preference, which is complete intransitive. In this case, we only have transitivity as a property of R. And we define the binary preference I given by, let's denote it as SAR, right? And it's actually the difference preference. So we will check the usual suspects or properties. We will check for the usual properties of indifference preference. Yeah. Preference I, which is reflexive, symmetric, and transitive. Okay. Yeah. First claim. First claim I symmetric. It's actually the easiest one to check. It's this follows trivially from I. From star, or the definition we have of I. Okay, so we have x, I, y, if and only if x r y and y r x. Let's rearrange terms. It's y r x and x r y. This is actually y I x, and therefore I is symmetric. Okay, and claim number 2, it's actually pretty straightforward too. So I is transitive. What do we need to show this? It's actually pretty easy. So let x, y, c be in the alternative set x, and x I y y I z, and we want to show that x I z, right? And we know that x I y means x r y and y r x, and y I z means y r c and c r y. And by transitivity of R, let's use another color. We have that x r y, which is these are two. We'll use this two, x r y, y r z. This implies xrz, right? And we'll use this two and CRY, YRX, then CRX, and therefore, so we have this implications, right? And we have that, therefore, we have that XIC, if and only if, XRC, and CRX. And we're by how we define the alternative set and the properties we defined. So we have that, therefore I is transitive. And claim number 3 is I is reflexive. And well, let for any, no, sorry, it's actually a mistake of how you talk math. Okay, so it's actually for any x, alternative set x, let, okay, R be the empty set, and then x are x for no x, right? Because there's nothing on my preference R, and therefore ix for no x. Therefore R well, R is not reflexive, and therefore I need not be reflexive. Right? Great. So that's question 1. And let's go to question 2. This is actually a pretty usual proof on linear programming courses. So given A in the matrices of space Mn, C and B are vectors in Rn, and suppose X bar solves the minimization linear programming problem. And we have to show that there's a solution to this LP, which is actually, sorry about that, which is actually what we call, what it's called, the dual problem. So this is the dual problem. And we have to show that the two problems have the same value at the objective function. Okay, so let's rewrite both LPs. Okay, so the primal P is minimize the cost function times the dot product of X bar such that A times X greater or equal than B, and X has to be feasible. And the dual problem, which is denoted by D, it's max the dual vector, okay, yt times b, right, the constraints such that aty is lesser or equal than c, and minus a transposed aty is lesser or equal than minus c. And this is actually at or a transpose equals c, and y has to be feasible. So to solve A, to prove A, let X bar be a feasible optimal solution for P. That's the primal. Then it must hold that the transpose cost function, or C transpose, minus y bar, this should exist because it's actually, if we have an optimal solution for the primal, then the optimal solution for the dual must exist. And as a moral homework, I would like you to prove this. Right, it's actually pretty straightforward. If you have any doubts, you can leave it in the comments. And this is actually greater or equal than 0, right? And we know that y bar transpose is the dual vector. So this means that C transpose is greater or equal than y transpose times A, and minus CT minus y transpose A. This is actually equality y transpose A, right? And on the other hand, let's transpose it again. C equals A transpose Y bar. Okay, on the other hand, on the other hand, we have that let's use this property. Let's plug it in right here. C transpose equals and let's multiply it by x bar, and that's equal to y bar transpose A times x bar. Let's associate this term, so it's y transpose A x bar, and as x bar is an optimal feasible solution for the primal, this is equal to b, right? So this is y t the dot product times b, and therefore y bar solves the dual problem. Okay, and let's prove b. The two problems have the same solution. Okay, have the same value, same value, objective function value. So let C star be the optimal value for the primal, and C tilde be the optimal. Yep, sorry about that. Optimal value for the dual, for D, right? And then C tilde must be y bar dot product B. That's equal to A times x bar, right? And you can transpose this, and that's equal to y t a, right? And that's actually C transpose. That's C transpose dot product x, which is equal to C star, and therefore both P and D have the same value. Great. Okay, so we finished the first two questions. I'm gonna do a part 2 video on the two more questions that we need to solve in order to finish this final exam. And great. So yeah, stay tuned for part 2. Thank you.